Mathematical Practice 1. Make sense of problems and persevere in solving them. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. In this webcast, we'll focus on Mathematical Practice 1, make sense of problems and persevere in solving them. So, to begin to get a sense of Mathematical Practice 1, make sense of problems and persevere in solving them, let's consider a scenario outside the math classroom. Imagine that you're going away for a weekend and need to run some errands before you leave town. You finish working at 4:30 and need to be on the road by 5:30 so that you can arrive at your destination before it gets dark. So now you have a problem to solve. You need to be able to run your errands within a 1-hour time span. As you think about solving this problem, you might imagine the order that would be the most efficient for making each stop. You could imagine each stop on a map and consider the travel time between each place. You may choose a grocery store that is not your usual grocery store but works better in this situation. As you are working this out, you suddenly remember that you wanted to go home after work to change your clothes before you left for the weekend. So you then rework your route given this new information. Though it was a challenge, you are finally satisfied with your plan. You have figured out a way to run all of your errands and be on the road by 5:30. You have even added a few extra minutes in case traffic is busier than usual. We make sense of problems and persevere in solving them all the time, and so do our students. Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to make sense of problems and persevere in solving them. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with Mathematical Practice 1, you'll be guiding your students to understand the problem before working toward a solution, plan a solution pathway, and persevere when challenged, expecting to adjust plans as needed. First, let's look at feature number 1, understand the problem before working toward a solution. To encourage learners to understand the problem before working toward a solution, you could ask them, what is the problem about? Or, what is the question that you are being asked? For example, at a lower level, if asked, how many square feet of tile are needed to cover the floor of an 8-foot by 12-foot entryway, students could sketch their understanding of the given problem in order to understand it. Encourage them to include the given as well as the missing information in their sketch. Now let's consider this higher level example of taking the time to understand the problem. After earning an 83%, a 79%, and a 94% on quizzes, what quiz score will you need to earn so that your quiz average will be 85%? At a higher level, as they work to understand the problem, students can organize the given information, define a variable, and show how the numbers and variables are related by writing an equation. This is also a way to represent the problem that incorporates the given as well as the missing information. By encouraging learners to understand the problem before working toward a solution, you'll see them discuss, sketch, or write notes about a problem before they begin to solve it. Now let's continue to the second feature of Mathematical Practice 1, plan a solution pathway. To encourage learners to plan a solution pathway, you could ask them, how could you get started? And then, what is the next step? For example, at a lower level, students could talk through their steps before solving a one-step word problem to practice the thinking process that they will use when solving these problems independently. First, read and understand the problem. Then ask, which operation should I use? Why? Then think, what do I estimate the answer to be? Is it more or less than 1? Is it more or less than 100? Then do the computation and write the answer, including the correct units. Finally ask, does this answer make sense? Does it match my estimate? You'll find many different versions of this problem-solving process. Find one or adapt one that works for your students. At a higher level, to give students a chance to practice planning a solution pathway, you could ask them to write steps for solving more and more complicated equations. For example, you could ask them to write the steps to solve an equation. Start by stating your goal. Or you could direct them to write the steps to solve a quadratic equation. Start by stating your goal. Or it may make sense to ask your students to write the steps to solve a system of equations. This also begins by stating the goal. If possible, direct students to do this activity in pairs or small groups. The intention is not to find the one correct set of steps, but to make the students aware of the steps that they are taking and to give them a chance to practice describing these steps. As they ask and answer each other's questions, they will be challenged to use precise language and will be reinforcing their own skills. They can test the steps by working through them on the board or by giving them to other students to try out on a sample problem. By encouraging learners to plan a solution pathway, you'll find that you will see them take ownership of the problem-solving process because they will have the language and skills to make it their own. The third feature of making sense of problems and persevering in solving them is persevering when challenged, expecting to adjust plans as needed. To encourage this, you could ask learners to show their steps from the beginning and ask them at what point they think they got off track. You could follow up by asking, what else could you do at that step? For example, at a lower level, you could ask students to fill in the missing numbers in grid puzzles like this one. Some students may try numbers that don't work, so they will have to erase and adjust their plan. With practice, students will come to see these adjustments as an actual part of the problem-solving process. At a higher level, students could work to rearrange formulas to highlight a quantity of interest. For example, you could ask them to solve each of the formulas that you see here for height. As they work to do this, it is likely that they will take some wrong turns in their process. Through discussion and analysis, they can decide the point at which they went wrong and go back to try a different step at that point. Students can check the new equations that they created by substituting actual values into them and making sure that the equation is a true statement. By encouraging learners to persevere when challenged, expecting to adjust plans as needed, you'll see them be more willing to accept that mistakes are part of problem solving. Each of the previous examples illustrates how students could make sense of problems and persevere in solving them. Now, let's watch this high school class as they make sense of problems and persevere in solving them.
My name is Therese Michael, and I teach geometry at Cedar Hill Collegiate High School in Cedar Hill, Texas. Okay, so what does the UPS check thing stand for? What's the U? What's the U?
U is understand.
Understand what?
Understand what the question is asking.
And what do you do in that part of the problem?
So you have to understand it and then rewrite it in your own words.
Put it in your own word, make it personal. Okay, what about the P? Yes?
P stands for the plan. And for the plan, we understand what the problem means, so we're going to have to use our deductive reasoning.
Okay, what about the solve, Carlton?
Solve, statement and reasoning. Use formulas, definitions, and theorems.
Oh, you sound good. All right. Formulas, definitions, and theorems. Okay, those are tools, right, to actually solve the problem, right? Each person will play a part. One person will be the U, one person will be the P, one will be the S, and one will be the check. So everybody is involved. So they will collaborate together on a particular problem, and they will use those steps to actually get to the answer. Why do I like this? Yes?
You said because it provides us like a way to think if we don't have an idea of what a problem means or how to work it.
Right. It gives you a thinking process. I believe that every student ought to have a thinking process. I don't want you filling on the paper or going through the calculator trying to figure out, that might be right. That's the answer on the paper. Wow, no. I need a logical process, and this helps me to ensure that you will think logically. Are you the solver?
Yeah.
Okay.
This question is asking about figures with parallel congruent bases.
Our answer was 89.91.
Collaborative group work actually brings the minds together. It's just like a think tank.
So far, I've said that we need to draw the pictures of both the cones and the cylinders, then label the height.
She has a good picture over there. That's good. We also did some writing to learn. Not only did they have to write down exactly how they understood the problem, and they are going to have to write down the plan of action. I want a complete sentence. Complete sentences.
We will need to make a right triangle to find the correct height.
Okay, very good. You're on the right track. Good job. The reason why I think the writing and all the questioning and the scaffolding is important is because what they have developed is learning why they are doing something. Okay, we wrapping it up. We finalizing the answers.
The conjecture is invalid because we can find a counterexample for it, which is the cylinder. So the answer is D.
Very good. Good job. So the final answer is which answer choice?
C.
C. Okay.
It was.
So if we're at the dinner table and I ask you what portion of the pie is left, you can find it? Okay, cool.
How did the students in the video make sense of problems and persevere in solving them? Did you see them understand the problem before working toward a solution? Did they plan a solution pathway? Did the students persevere when challenged, expecting to adjust plans as needed? All three aspects may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to practice the UPS check, problem-solving method in small groups. This activity would be meaningful and engaging at all math levels and would also provide ample opportunities for learning and practicing academic language. How could you adapt this activity to use in your own context? In conclusion, I want to share this poster that summarizes Mathematical Practice 1. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to make sense of problems and persevere in solving them?